Broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, ladies and gentlemen, wherever you might be. Welcome to the Virtualization virtual chapter for the month of April. We are very fortunate to have James from the UK with us today talking about Docker on production. Would you run it there? So this is something that we're all quite interested in. Is it seems that virtualization VMware might eventually be replaced by containers. So if you have not registered for Past Summit, please do so. It's the cheapest it can be for right now. It was cheaper in January, but there is a code if you need it. Just send me a note, and it'll give you $150 off to Past Summit. So with no further delay for James, I'm going to let him take over. Thanks again, James, for coming on to talk about Docker.
No worries. Thanks, Tom. Okay, so today we're going to go through whether it's a good idea to run production SQL Server on Docker. So you can find me on Twitter. Any questions you have of this, my email's there. Comment on my blog, anything you like. There's a few posts on the blog that led to this talk. So some of the things we're going to cover is, first of all, how Microsoft is changing and what impact that's had and how that's really got us to even be asking this question. Is this actually a good idea? If we were going to do it, what do we need to be able to do it in production? Is anyone doing it? How would I do it? And if all those things are good, then what's actually stopping us from doing it? So a little bit about me. Started out as in IT support as a general sysadmin, then worked my way up, became a DBA, and really for the last couple of years I've been more of a data engineer with strong SQL skills, but looking into much more, getting towards the analytic type stuff, hopefully machine learning and a bit of Python chucked in there as well. So a little bit of a history lesson to start off. The relevance of this will probably become more clear as we go on, but I want to start with the fact that 5 years ago, this is what the top echelons of Microsoft looked like. So we've got obviously Big Bill in the middle there, started the whole thing. But we've got Satya Nadella, who at this time was lead of the Server Tools project. So SQL Server was part of that. I think the 2012 release was under his tenureship at that point. And then you've got Steve Ballmer, who joined Microsoft as something like employee number 28, I think. Joined as a business manager, worked his way up, obviously been there a long time, and eventually got to be the head honcho, and he was at this point. Bit of an interesting guy. This was like one of his rants at a conference, just shouting developers, developers, developers. I think it was a release of Visual Studio, and to be honest, I think this was in the early days of .NET, and it got a whole generation of developers into the Microsoft ecosystem. But an interesting method to do it. Horrible, weird, bit creepy. Salesman. So that suit, the image quality is poor, but this guy, he is a businessman, and to lead a tech giant like Microsoft, you could kind of see his style. He was basically, everybody should be using Microsoft to do everything. So if someone comes out of a fancy or a clever idea, then it's going to be Microsoft are going to create their own version of that and try and get that out. So he made a lot of money. So I think it was something like tripled the revenue of Microsoft in his tenure, which earned him a lot of money. He bought his own basketball team. But this is when things started going a bit wrong. So there was a huge acquisition of Nokia, and I think Ballmer was still due to be CEO today. But when this acquisition started to go sour, it looks like the pressure built up, and Ballmer decided to hang up his shoes early. So then this happened. So Nadalja got given the #1 spot, and really early on, we started to see some big changes in Microsoft. So this real swing on their view towards Linux, which at times was the competition during the desktop wars, which Microsoft ultimately won. But to now start embracing the open source world and the Linux world, and really moving from a company where everyone should run Microsoft to do everything, it's more like everybody should use Microsoft to solve their problems, and Microsoft can solve those problems with the best tool for the job, which may not necessarily be a Microsoft tool. But it's also very nice if you use any open source tool to solve your problems in the Microsoft cloud. That's the bit they don't push, but I think that's pretty clear. So this is also true. So Microsoft also loves Docker, it loves Linux, but this became clear very early on. So about 4 years ago, probably 4.5 years ago now, a partnership with Docker was announced. And then in 2016, we start seeing Windows containers. SQL Server 2017, its big feature was that it could run on Linux. And whilst an amazing achievement, a lot of people questioned the utility of this. I mean, how many Windows houses are going to start running SQL Server and Linux? What do they actually gain from that? And are there really that many people out there, like Linux houses, that want to run SQL Server? But when you think that Windows containers aren't supported in production, then being able to run SQL Server on a Linux container means you can then run SQL Server on a container in production. So that is probably the reason we saw SQL Server 2017 on Linux. Also, I expect when you're building a cloud platform and the amount of scalability that you need in a cloud, containers are being used all over the place in the background. And if you can easily scale SQL Server because it's on containers, this technology is probably being used in the background of Azure, I would guess. So very recently, a couple of months ago, there was an announcement between Microsoft and Docker again, and they've come up with this cloud native application bundle, which is an open source kind of standard for wrapping applications so that they can run on any cloud platform. We're yet to see if there's going to be wide adoption of this, but it just goes to show that these two companies are working quite closely together. So before we get into whether SQL Server on containers is a good idea, I'm just going to do a quick rundown of what a container actually is and how it differs from a traditional VM. So anyone who knows this, bear with me, but we'll try and get through this as quickly as possible. So the big deal about containers is isolation. So imagine I'm writing two pieces of software, and I'm writing them on my same laptop that I develop code in. And they're both in Python, let's say, and they both use libraries. So libraries are essentially someone else's code that's published and anyone can use it, so you don't have to rewrite code. So maybe I'd have a library that speaks to the file system, or a library that sorts out parallelism or something like that in my code. So imagine I've got one program and I write my program and it uses that library, and then a year later on the same machine I write another program and I want to use that library, but there's a new version of that library. Now if I update the library, my old piece of code may no longer work. So there's a dependency between these two pieces of code on that library. Now I could update the library and update my code. That is probably what I should do, but it's not always an option in business. You know, it may not be the priority to update that code. So what we need between these two pieces of code is isolation. So in the Python world, one of the ways we can do this is with a thing called virtual environments, which is essentially, well, let's just install Python twice and have the old version of the library here and the new version here, and the old code uses the old Python and the new code uses the new Python. That's essentially what virtual environments in Python do. So that gives you an isolation, that kind of works. But imagine if my code made use of environment variables, which are part of the operating system. Now, imagine if I wanted those environment variables to be different for different pieces of code. Well, really, in the past, the only way to deal with that type of stuff, or any sort of operating system level configuration piece, could be something on the file system. The only way to get the isolation was to run those in either separate physical machines, but then we got virtual machines, so that gave us better density. We could run the two pieces of code in their own virtual machine on the same physical machine. So we don't need separate physical machines anymore. That's what virtualization gave us. But there's still a big overhead there. There is still a big overhead because a virtual machine replicates the hardware and it replicates the kernel of the operating system. So where containers come in is a container uses the kernel of the host machine. So you've got your physical machine, and when you turn that on, it needs to boot up the kernel, the core of the operating system. And then once that's booted up with VMs, it then has to boot up another kernel for each of my VMs and then boot everything else up. But a container will go, okay, the physical machine's come up, the kernel's up. The container will go, I'll just use the kernel that's already running and just load the extra bit, which is essentially my code and anything I've configured to be in the OS to run. So it's really quick to boot up because it doesn't need to boot up its own kernel. It doesn't need to replicate hardware or anything like that or emulate hardware. It's just that user level layer with my code and any dependencies that my code has. So the density now is much bigger than VMs. So now we're using much less resources to do similar stuff. Now each container is just a process, because remember, this isn't a whole replication of a physical machine like a VM. And the idea is that we only run one process inside a container because we want isolations. There's no point running multiple things inside a container because then we get back to the same problem if they have dependencies. So we run one process in one container. So a container essentially is just a process. So if you run a container, if you were to get, Microsoft SQL Server container and run it on your local machine, that will just show as a single process when you look at Task Manager on your host machine, because that is essentially what it is. So the host's kernel matters, because if these containers are using the host's kernel, then if you're booting up Windows containers on a Windows host, well, the Windows containers need a Windows kernel because Windows needs a Windows kernel. That makes sense. So if you try and boot up a Linux container, it's going to go, oh, where's my Linux kernel? Oh, it's not there. This is a Windows machine. I can't run. Now, some of the Docker tools and other things do some clever stuff where actually they spin up a Linux VM in the background and Linux containers could then use that kernel. But, we're getting turtles on top of turtles here, but okay for local development, but probably not in production. So I've mentioned we're going to get fast boot times because the kernel's already up. We don't need to replicate hardware. They're declarative. Now this is huge. So with Docker, you can basically have a thing called a Docker file, which is a YAML file, which is essentially slightly structured text file, where you can say, right, I want to have a container that has SQL Server and it has availability groups enabled and something else enabled. I don't know, whatever else. And the Microsoft vanilla SQL Server image doesn't have that. But what you can say is right, well, I want a custom container here. So you can get a Docker file, which is just that text file, and say at the top of it, say, well, from Microsoft's base image, essentially, I want to run this script inside that container, which enables these features. And then I want to call this James's SQL Server container. And that small declarative piece of code then means when I spin up my container, it's all ready to go. It's got all of those settings straight away. It's got that fast boot. and we're ready to go. And the great thing about it is because of that first line where it says from Microsoft's base image, if they update their image, the next time I rebuild mine, I get their updates straight away. And we have to manage that, and I'll talk about that more as we go on. But that declarative nature means I don't necessarily need to check that all of my SQL servers are set up correctly. I know they are because they're all derived from exactly the same declared image. And because it's declared in a text file, it can go into source control. So suddenly we get a lot of wins. So when you declare what you want your containers to look like in that text file, when you build that, you get an image. And you can think of an image almost like an installer in a way. If you run that image, it will give you a running version of the container. So, and if you run it multiple times, you get multiple versions of that container running. So you can spin up multiple ones from a single image. So you can imagine if we had a farm of servers, if they're all running instances of that one image, I know they're all configured exactly the same. I can plug in variables to give them different names, different IP addresses at runtime, but it really means we can scale now without having to worry about, oh, did someone change the setting on that one? Have we got drift? So here's a big one when it comes to data. The stuff I've mentioned before, and really containers in general, are perfect for stateless objects. Perfect, you know. They're declaratives. You can spin them up, let them do some work, and then just throw them away. They're not designed to stay around like VMs. You know, it's pets versus cattle. You know, VMs are pets. You look after them. People change them. You have to maintain them. Whereas containers are cattle. You just get them going. You don't look after them. They come and go in a cycle. You have no attachment to them. And because they're like that, they don't save data. By default, they're stateless. But we can get around this. You can map storage into a container at runtime. So you've got your image, and you say, this image uses this volume of data when it's running. So it comes up, sees the volume, and it maps the data into a container, and then you've got your databases. You kill that container, it's gone, but your data still lives in that volume. So we'll look at that a little bit more. So ephemeral is what we're talking about when we just spin them up and throw them away. And yeah, stateful systems in there. Any DBA who starts being told that their databases could just disappear, because that's the nature of containers, gets worried, but volumes should make us feel a little safer. So SQL Server Docker, it's a big bulky thing on a new small lightweight thing. Is it gonna really cause us problems? Well, it's great for dev and test. It really is good for dev and test, because you can imagine if you've got an image with your test databases already in it, and you can just say to someone new who comes, oh, okay, install Docker on your machine, or it's already installed on your machine, and just do a Docker pull to get our images, and then just run the script and it spins them all up, and there you've got a full environment really quickly. I mean, how many people see people being onboarded or have been onboarded at new companies and spend a day, 2 days setting up an environment to then be able to start developing? This can really speed that up. And for testing environments, imagine you've got 3 environments. You've got dev, you've got test, you've got production. And you basically need dev and test to be exactly the same as production. So even for especially for your SQL Server. So imagine you switch on, I don't know, full text search in production. You need to go back and switch that on in test and dev, but there's no guarantee that you will. And the problem with that is that you end up developing and testing your code in an environment that is not like production. You know, whenever I do this talk and ask people to raise their hands if their development or test environments actually look like production, it's very rare that anyone actually ever puts their hands up. But this technology could really help us here, because imagine if all of these environments are derived from the same image. There's no way they can be the same. And if we want to turn on full text, well, we change our declarative text file to say we enabled that feature. And the next time these environments are deployed, we've got all those settings. And we deploy them on demand. So imagine you're writing a product that needs to run on your client's infrastructure. So say you're building a CRM and people run it on-prem. And you need to make sure that your CRM supports SQL Server 2012, 14, 17, 16, 19, with AGs, without AGs, whatever. And you probably need quite a few test environments for that, because you need a separate instance for each version of SQL Server. It's probably going to mean quite a few VMs to do that. You could stack them on one, but it's going to be difficult to keep them all up to date. Every time you make a change in production to your setup, you need to go back and make it to all of those test environments. And imagine if you are using multiple VMs or multiple physical machines to do that. You've got those machines, they're just sat there burning CPU cycles whilst waiting for tests to come in. So if no one's testing their code, they're just wasting resource. So imagine if you just had a smaller amount of compute, which can run any of those environments on demand as the test comes in. So the test comes in and goes, I need to run 2014 tests on SQL Server 2014. Okay, well, I'm just a bare metal piece of compute. Spin up the SQL 2014 container images, run my tests, get the results, kill all those containers. I don't care anymore. And you know what? It's taken us too long to run our tests. So why don't you spin up 2 of the 2014 containers and split our tests in half and run them in parallel, or 4 or 8, depending on the compute we've got. So we're getting better density. We've not got stuff sat around going stale as often. Our production environments could be using exactly the same images as our test environments, which are all source controlled. You know, it's the DevOps dream, it's infrastructure as code. Well, there's the sales pitch. So that has got to be one of the reasons we'd use it in production. So we've got that environment maintenance piece. I think that is one of the biggest problems in IT. It is keeping all of those environments up to actually looking like what production is. And when it comes to patching as well, at the moment, imagine if you kept all of your environments bang on what production was, maybe using some of the PowerShells at DSC, or if you're using there's all sorts of automated stuff out there. But a patch is released, so you have to patch all of your environments. There's no getting around that. You have to patch all. You can automate it. You know, it could be kicked out by WSUS or whatever, but you still have to patch all of them, and you have to patch production. But imagine with a container, is you go, well, Microsoft have released a patch. My from statement in my Docker file says from the latest version. So all I need to do is say, rebuild my image, and then all of the environments, we can just say, well, just start using the new image. You know, the databases are in volume, so that container can come down and then bring it back up again. It's the new image. It's got all the updates. We don't need to patch anymore. We just need to rebuild, which is just a command saying Docker build. We get the patch from SQL Server. It's now in our container, and we just send it out. Or in the test environments, it just starts getting used on demand. Now, we can gate that because we may want to roll out the patch in test environments first, because we want to test the patch as well. But we can do all that. There's no need for things like WSUS and stuff like that. And you definitely don't need to sit there clicking for installers on every server. Really shouldn't be doing that. So, reduced patching, the dream. One tool to rule them all. So imagine if everything was in containers for your production, your web servers, your application servers, and your databases. Now I don't need to be a physical machine expert, a Hyper-V expert, a VMware expert, or one of the cloud experts. I just need to know how to manage containers. And if everything is in containers, well, maybe that's why some people would want to do this. They've gone, well, we've containerized our web apps and our applications. We don't want to have to deal with our data layer and with different technologies. We want to house, so we just want to use one tool to manage all of our infrastructure. That could be why we want to bring the SQL Server production into containers. There's potential for easier, high availability. So containers give us a chance to do high availability without Windows clusters, and I'll cover that in a bit. And there's a outside chance, and I think Microsoft are trying to get us close there, to give us elastic horizontal scaling for read-only data. So imagine you had an AG and you're offloading your read-only to secondary readable replicas. Imagine if you could, just by pressing a button up and down or putting in a command, scale the amount of read-only replicas up and down to accommodate the load that's coming in. Might be possible. So if we're going to do this in production, what we're going to need? Well, we need to be able to persist our data, because we can't have containers just disappear and take our data away. So as I've mentioned, we're going to do that with volumes, but we'll get into that a little bit more. We're going to need to understand the security model around containers. Is it a concern that every container running on your host are all sharing the same kernel, which is the kernel of the host? Maybe. High availability, I need an answer for that. I need to be able to run this in high availability. I need disaster recovery. These are all prerequisites of production. I need to understand the licensing, and what am I going to, is my monitoring still going to work? And I think we've covered how we're going to do patching. So to do all these things, we're probably going to need a little bit more than vanilla Docker. Now, if you've ever seen an introductory talk to Docker, or you've read a tutorial online, a beginner's tutorial, it will go something like this. Go to the command line, type a few commands into Docker, which will give you an image of your choice. Maybe you just get the Ubuntu image, and you say Docker run, and bang, there you go. And magically, on your Windows laptop, you've suddenly got an instance of Linux running, and you can log into it and do what you want. And you can blow that way and spin up another one, and it's like new, and it spins up really quickly. And that's it. But in a production environment, that isn't going to work. Like, you're not going to say, okay, I've got 3 physical hosts because I need redundancy. So, okay, I need 8 web servers, right? Let's go on the command line of host 1. Okay, spin up, I don't know, 3 web servers. Let's go to host 2, spin up another 3, go to host 3, spin up another 2. Oh, host 3 disappeared. Okay, right, I need 2. Okay, host 1, let's add another 1. That is not going to work. We need something to automate all of that for us. And that's where orchestration comes in. So I've got a few on here, but Kubernetes is basically one, this area. So orchestration, or I'm going to talk about Kubernetes, is essentially a management layer on top of your containerization run engine. So Kubernetes will take YAML files, so these slightly structured text files, and you'll say, right, I've built a Docker image for what my web server looks like. Now, Kubernetes, I know in production I need 8 of those, and I want you to put a load balancer in front of them and make that, the IP of that load balancer, publicly available so we can address websites to it. And I need you to be able to always have 8. So if one of the nodes drops and we're down to 2 nodes, you know to spin up If there was 2 on that one, another 2. You need to keep me at 8. Same thing with my application layer. I want to be able to scale that horizontally as well. So put a load balancer between that and the web servers, and then maybe something like that at the data tier as well, although horizontally scaling data is a bit more difficult. This does that for us. It also allows us to go, okay, Kubernetes, here's some storage, cluster it amongst the nodes, and make that storage available at runtime to my containers. And don't let more than one container write to it at the same time. The others can read from it. So we can start doing stuff like that as well. And you can see where Windows clustering at the container level probably doesn't make sense, because imagine we've got a clustered storage and we're telling Kubernetes we want one primary SQL Server instance. So run that, and it's running on node 1. Node 1 disappears. Well, all you have to do on node 2 is fire up the same image. Starts up another container, looks for the same storage, sees no one else has got it, bang, we're up and running. That has done the same thing that a Windows failover cluster does, but we're not configuring a Windows failover cluster to do it. We're essentially using the same clustering technology for a whole stack without, well, it's got complexity. I can't say without the complexity, but we've got that consistent technology, that one tool to rule them all. So OpenShift is Red Hat's distribution of Kubernetes. So this gets the Red Hat stamp of approval. They roll their own images where a lot of the images that you'll find publicly have a lot of security problems. And people are trying to work this through. And Red Hat have gone, well, I think we're just going to make our own version of these. Like a lot of the Linux ones, the service, so say if you were to get, I don't know, Apache web server container, it runs as root. Now, I'm not sure if the Apache web server does, but a lot of, I think the Mongo one does. So a lot of them run as root, which is a security issue. So Red Hat trying to address that. They create their own images of certain application stacks, and they try and make sure it doesn't run on root. And they try and make sure that all of their images are compatible with each other, so all the versions work. So OpenShift, you have to worry about less. They do more for you, which is good. Swarm is Docker's proprietary orchestration platform, very different from Kubernetes. Kubernetes, as I said, does seem to have won this area. Now, there are, on some of the big cloud providers, they have versions, like hosted versions of Kubernetes at various different layers of complexity. There's ones that really are like Kubernetes, the ones that just do everything for you, just give it the container image, and it just manages all sorts of things in the background. So we've got different options there, but we're going to need some orchestration. Now, we're probably going to need custom images, because like I said, Microsoft's image is a vanilla one. It doesn't have AGs enabled. It doesn't have full text enabled if you're using that. There's a lot of things that won't have enabled, and we'll want to enable the features that we require. So I doubt that it'll have query store enabled and stuff like that. What do we do with antivirus? Now, the Microsoft image isn't going to have our antivirus client into it, so we're going to have to embed that. Monitoring agents. We're going to have to embed our own monitoring agents and maintenance tools. So maybe you like to have SB who is active or DBA tools on your SQL Server instances. Well, you're going to have to bake them into your own images. And all that is in that Docker file, that declarative text file, YAML file. You're just essentially layering things like that on top of Microsoft's base image. And it's all doable. So, is there anyone actually doing this? Well, when I first started this talk, this talk really came from this question. So I'd go to some of these introductory talks to Docker and SQL Server with Docker, and this question would invariably come up at the end. It would be, okay, this all sounds cool. I see potential benefits and stuff like that. But is anyone doing this in production? and for a long time couldn't find about anyone doing production. There was one Wall Street company in the Microsoft marketing for SQL Server 2017 on Linux who were running it in containers, but could never find out a lot of details about that. But in the last year or so, I've started to hear, I think it's two or three. So I've put the feelers out on Hacker News, Twitter, places where I do talks, places where I go to see talks. So I put this question out there. I think I'm at about 2 or 3. So this could change, but adoption isn't huge yet from what I hear. Now, if I was going to do this, how would I do it? So, well, this technology comes from the open source world. Containerization has been around in Linux for a long time. Docker came around about, I don't know, 8 years ago or something and made it much easier to use. But it's come from the open source world. So let's look how they do it. So there's a project around Kubernetes called KubeDB, and this project is designed to simplify the running of relational databases, although I think they support Cassandra and Mongo as well, in Kubernetes. So when you deploy a database to Kubernetes, you need to tell it about how you want it to manage the storage, how you want it to manage, how many nodes you want, how that's all going to work. KubeDB aims to really simplify that process, but it doesn't support SQL Server yet. It supports Postgres, so if you're using that, it's probably a good way to go. Now, another Postgres thing is Crunchy. They are a consultancy for Postgres, and they came up with this, which was complicated enough for me to think it was cool and worth including. But essentially, what they're trying to do here is they're trying to break the monolithic relational database management system into its constituent parts, because Kubernetes and containerization is really for people who want to scale, and vertical scaling only takes you so far by adding more CPUs and RAM. But if you can horizontally scale, it's far more powerful if you can account for the complexity that brings in. Kubernetes tries to make that easier. Still very difficult with relational database. But you can see what they're trying to do here. So they've pulled it apart. So we've got up here the incoming application request comes into this PG pool container piece. Well, this is just a listener. So now that it's been pulled out into a separate container, if this was being overwhelmed, we could spawn more listeners horizontally to handle the load. We've got a primary node down here with a container that's watching it. So if this container went down, this replica one would take over. Now they've got some replication going between these. Each one has its own volume, as you can see. They've got monitoring built in. So they're using Prometheus to collect metrics, and they're using Grafana to be able to display those. And you imagine if you had a farm of Postgres servers, but these could potentially in the near future be SQL servers. If you had a farm of these and you had just one Prometheus capturing those metrics, as you add more to your farm, you're going to want to scale Prometheus. So the fact that we've separated stuff out, such as our scheduler here, so we've got a DBA cron, so this is essentially like the SQL agent and SQL server, but they've pulled it out from the monolith of the relational database. So it means we could have one schedule for all of our instances, and we could scale this horizontally if that scheduler is struggling to do multiple jobs at the same time. We've even got a container that restores our backups. Well, it takes our backups, and then we've got another container that then restores them. So we're testing our restores. And imagine if that farm scales out, we can't restore enough backups quick enough. Well, just spin up a few more of these restoring containers, and then we're scaling with our farm. That's what we're trying to do here, which I thought was a pretty cool idea that Crunchy had got to. So in the SQL Server world, we try and do this replication with AGs, and the challenge is to dynamically configure those AGs as things change. So how do I like to do it? Well, to be honest, I'd like to just use a cloud container service. So I build my custom images, I know what I need on my SQL service, and I deploy them to the cloud, and I let the cloud just do everything because I'm lazy. But if that's not an option because of certain data constraints, if I did have to go on-prem, it'd be nice to use OpenShift because they're going to secure a lot more things for me and I have to worry about that type of stuff less. And I'm going to have to provision some clustered storage to it. I'd like to use Windows containers because every DBA I hire is probably going to be a Windows guy. It's almost guaranteed. A small percentage of them might know some Linux. I don't really want my DBAs to have to support SQL Server running on Linux containers, because imagine if there's an I/O issue, everything's going slow, and I've got a DBA that can't use Perfmon to see what's going on at the I/O level anymore. But if it was Windows, perhaps they could. But that could change. So are we ready for production? Well, we can persist our data. We've got clustered storage in some of the Kubernetes. It can manage it for us, so that's good. We can take our SQL Server containers down and bring them up, and they'll find the same databases as they were. It's exactly the same as failing over a failover cluster, or just turning an instance off and back on. Security, well, this one's interesting because we do have multiple containers sharing one kernel, which is the kernel of our host. So imagine one of your physical hosts in your Kubernetes cluster is running a couple of web servers and your SQL server. So imagine there's an exploit on your web server which allows the attacker to escape to the kernel, essentially to the host. So they're in the kernel of the host. That probably leaves my SQL server open at that point as well. Now that is a concern. Now there was a document, a blog post that went out a couple of months back now that got a lot of traction, and it was talking about, is the future of Kubernetes virtual machines, which seems counterintuitive as we've gone all this way to make containers run better. But the idea would be you'd have your physical nodes, and imagine you want to do a multi-tenant solution. So I've got 2 web servers, a SQL server, and an application server for client number 1. And then I've got client number 2 that have got their own ones as well. I wouldn't want to have this tenant segregation, but let's just say I have to for some compliance reasons. Now, if there's an exploit in client 1's web server, if client 2's web servers are running on the same node, that could allow that exploit to spread. But imagine if on each of my physical nodes, I ran a virtual machine for each client, for each tenant. So the virtual machines would give me the kernel that the containers for each client would use. So you'd have physical machine, virtual machines, and in each virtual machine, you'd have containers for that client running. So if there was an exploit that went to client 1's kernel, it wouldn't get to client 2's. So there's a lot of talk going on in the community as well at the moment of using virtual machines. And when I say virtual machines, these aren't like the ones we're using at the moment. You know, they're not full-fat virtual machines. They just give enough that a container can use as kernel. So it's not going to do a lot of the user space stuff. So it may mean that when you first boot up your Kubernetes cluster, it takes a little bit longer because it's got to boot up these virtual kernels. But once they're up, they're up. And containers, as they come up and down, they can be quick as normal because their kernel is already up and running. So it's an interesting thing, and that may make a lot of people more comfortable with the security model. So high availability. Well, orchestration gives us this in the same way failover clusters does. Disaster recovery, well, this works in the same way. We're still going to back up our databases to some clustered storage, and we can, at the storage layer, at the block level, we can replicate that to another site. That's going to work in exactly the same way. Licensing is the same as in VMs. So for every container you run with SQL Server on it, you have to pay for that SQL Server. So that's okay, but that takes out a lot of the elastic horizontal scaling benefits that we've gone down this whole container route for. It makes it really expensive. Unless I license at the physical node layer, but I might need three nodes to support my whole stack, my web servers, my application servers, SQL Server. I might actually only need 2 nodes to do my SQL Server ones. But if I'm going to have everything in the same cluster, I'm going to have to license all 3 of those nodes. And that's going to be really, really expensive. So Microsoft licensing and containerization, there's a little bit of a clash there, in my opinion. Monitoring, well, monitoring, we could bake in our monitoring agents into our custom images, but I don't think that's very good, because imagine monitoring agents tend to get updates a lot as the product evolves, and I don't really want to redeploy every time my monitoring changes, and I don't really want to patch it either. So in this Kubernetes world, that's not really the way we do things anyway. The way we do things is the process that's running inside the container just chucks all of its logs out to what would be the screen if you were on that machine. But Kubernetes sees what we call the standard out. Kubernetes sees all these logs, and we can have, like we saw in the Crunchy setup for Postgres, something like Prometheus, some sort of log collector, log stash, whatever. And it can be configured to every container that's up and running, collect some metadata about it. This is a web server, this is its IP address, whatever else, and just pull all its logs into one central store. Then we could put something like Grafana or Power BI or whatever on top of that to visualize those logs. So there's a different mentality and a way of doing that. Patching is a different mentality and way of doing that as well, which we've covered. So we could say, with that criteria, that we are ready, that we have some caveats, there's a lot to learn, but we can see some benefits, definitely. So the question is, would I do this at this point in time? And to be honest, the answer is no. So sad medallion there. And it's not because I don't believe in the technology, or I don't think the technology isn't good. Really, I'm just not convinced it's a great fit. So SQL Server is a monolith. It's a big beast. You know, it's not a stateless application that really lends itself to horizontal scaling. But people may say, well, we want to manage everything with one tool. So, okay, maybe we'll make it work in there. Is the tooling there? So if Windows containers aren't supported in production, that means I've got to run my SQL Server on Linux containers. And is the tooling in the SQL Server world that allows me to look at stuff like I/O very easily? I know I've got DMVs, but it feels like there's probably going to be gaps there. You know, am I going to be able to deploy DAC-backs on a Linux machine when I don't have MS Build? I don't think MS Build has been ported to .NET Core yet. It's all these types of stuff that are a concern. Older versions of SQL Server, if you're stuck on older versions of SQL Server for whatever reason, Microsoft is not going to publish container images for those versions. So I think 2017 is the earliest one. They used to do it 2014, but I think that's gone now. So if you need to run on, or maybe 2016 is the earliest one they do. If you need to run on 2016 or below, then you're not going to be able to. There are some people out there that will help you with some of their tools. I wouldn't suggest this if you need to run older versions of SQL Server. Is your app running in Docker? You know, containers are really great for stateless stuff. They can be great for stateful stuff like databases, but they're much easier for stateless stuff. So if you haven't put your web servers into containers, don't even consider putting your databases into containers, because you're just starting with the most difficult problem. It doesn't make sense. There's absolutely no reason why you couldn't have your web tier and your application tier in Kubernetes, making use of that horizontal scaling, and still keep your relational database out on VMs or physical machines even in a clustered way, and those containers can talk to it. That seems to be quite a good compromise to me. And the licensing model really hits us here. I mean, it hits us anyway. I mean, there's a gotcha I didn't mention earlier. If you're saving licensing costs by running multiple instances on one machine or one VM, that's not going to work in this world, because Microsoft's container image of SQL Server only has one image on it, one instance on it. So if you've got 3 instances on a VM today and you're paying one set of licenses, if you spin up those 3 instances in containers, you've suddenly tripled your licensing costs. There's something to look out for. But this is the biggest reason I would say no today. And it's skilled staff. I touched on it earlier. I want my DBAs to be comfortable where they are. If they're not comfortable working in Linux on Kubernetes, then I need to find someone who is, and it's going to be really hard at the moment to find people who are. But I don't want to end this talk on such a negative point, and I really want to go back and highlight that history lesson that I did at the beginning, which showed the change in Microsoft when Natalia took over. From old school Microsoft to the new school. So this is not the new school. This was a quote that was apparently uttered by Ballmer in a meeting, and it became quite famous. But essentially, Linux was seen as a cancer. Now, that history lesson at the beginning, I hope, showed that how Linux is no longer seen in that light, and how much Microsoft has changed in 5 years. So in 5 years' time, we may, as DBAs, as administrators of virtualization or containers or Kubernetes, we may be very different people as well. You know, especially if you're going down the route of doing Microsoft certifications and stuff, it may be that there's new technologies to learn, and that in 5 years, the workforce looks different than what it does today. So this technology, SQL Server containers, I don't believe it's going anywhere, because I believe it's being used in the behind the scenes in Azure. And it may be that more and more of us see the benefits of this way of working, and some of these blockers that I've mentioned start to disappear slowly. So with that said, I think that's me done. Any questions, please do get in contact. Do let me know. I'd love to answer as many as possible. Thanks for listening.
James, I've got one answer. Well, one question for you. You answered the other one in the last few minutes on licensing.
Okay.
Are there any use cases or architectural diagrams for SQL Server running on Docker containers that can be shared?
Wow, yes. Yes, it's all really Microsoft documentation though. As I said, it's a struggle to find people actually doing this in production. So I have not seen anyone other than Microsoft put that type of stuff out. So I would suggest that's your source, and it will not be difficult to find.
Okay. All right. Ladies and gentlemen, thank you for attending today. I will be uploading this to YouTube later on, probably by the weekend. And thank you very much for an educational review of containers and stuff, and I appreciate it, James. Thank you and goodbye,
So
everyone. Have a great day.